Hi, nice to have you. Today we are going to be looking at empirical formula and molecular formula of a compound. Of course, we already talked about the chemical formula of a compound, but today we are going to go in details to talk about different types of formula that a compound can possibly have. Of course, a compound can have empirical formula, molecular formula, and in some cases structural formula. But we are not going to look at structural formula today. We will do that when we talk about organic chemistry, where we are going to look at how elements or atoms bond together in different forms to give us the different structures. So today we are going to concentrate on empirical formula and molecular formula of a compound. Now, what then is empirical formula? When we say empirical formula of a compound, it is simply the formula that shows the number of atoms that are present in the compound. It only shows the proportion of the atoms and the way they combine in the compound. It doesn't show in details how the atoms of the elements are combined, but it just shows the number of atoms that are combined to form a molecule of the compound. While the molecular formula goes in details to show the actual number of atoms of the individual elements that are present in the compound. There are some cases in which the empirical formula and the molecular formula of a compound can be the same. Let's see examples of some compounds and their empirical formula. So we have empirical formula of water. Empirical formula of water as H2O. We also have the empirical formula of ammonia. Empirical formula of ammonia as NH3. Okay, so these are empirical formula of some common compounds. Then we have a molecular formula of water also is, we have the molecular formula of water as H2O also, and the empirical formula of water of ammonia is also NH3. So there are some cases where the empirical formula can be the same as the molecular formula, but it is not the same case with some organic compounds where we have an organic compound like glucose, where the empirical formula is CH2O, while the molecular formula is C6H12O6. Okay, so it is not in all cases that the empirical formula and the molecular formula is the same, but there are some scenarios where you can have the empirical formula to be the same as the molecular formula. So just as rightly said, the molecular formula goes in details to show the actual number of atoms of the different elements that makes up the compound. Now let's take a look at some examples on how to calculate the empirical and molecular formula of a compound. Let's take a look at our first example here. Now we have a question here that says an organic compound contains 60% carbon, 13.3% hydrogen, and 26.7% oxygen. Calculate the empirical formula of the compound. Calculate the empirical formula of the compound. That is, we have to determine the simplest formula of the compound. Okay, now we can do this by simply dividing the percentages of the different elements by their atomic masses. So let's take a look at the component elements that are present in the compound. So here we have the component element as our first step here. So we have component element as we have carbon, we have hydrogen and oxygen. Okay, carbon, hydrogen and oxygen. So the percentage composition by mass. Percentage composition by mass of the individual elements. So we have carbon is 60.0, hydrogen is 13.3, while oxygen is 26.7. So these are the individual percentage composition by mass. The next thing we do is to divide the percentages by their atomic masses. So we say divided by their atomic masses. Divided by their atomic masses. So here we have 60.0 divided by atomic mass of carbon, which is 12, and here we have 13.3 divided by 1, and here we have 26.7 divided by 1. Now by doing this, we can now have the numbers as 60.0 divided by 12 gives us 5.0. 30.3 divided by 1 will give us 13.3. While 26.7 will give us, divided by 16 will give us 1.67. So these are the individual decimal fractions that it will give us by dividing the percentages by their atomic masses. The next thing we'll do is to look at the numbers we have here and select or pick out the smallest number and divide all through by the smallest number. So we say divided by the smallest, number. Okay, so divided by the smallest number, we have 5.0 divided by the smallest number here is 1.67. Here we have 13.3 divided by 1.67. Well, here we have 1.67 divided by 1.67. Of course, 5 divided by 1.67 will give us 2.9, while 13.3 divided by 1.67 will give us 7.9, and this will give us 1. So we have been able to divide the masses, the percentages by their atomic numbers, and we will also be able to get the smallest digit, and we've divided all the numbers by the smallest number. So given this now, the next thing we do is to get the mole ratio of the different atoms. We can do that by taking the approximate value of these numbers or rounding them up to the nearest whole number. So rounding this to the nearest whole number, 2.9 will give us 3, while 7.9 will give us 8. Here is already 1 as a whole number. Now the empirical formula of the compound is, so we have empirical formula is C3H8O1. So there is no need of indicating this one here according to science, so we just write as C3H8O. So this is the empirical formula of the compound. It is very simple, isn't it? Now let's look at another situation where we have been given the molecular mass of the compound, and we are asked to find or to calculate or to determine the molecular formula. So we can do this by first obtaining the empirical formula, after which we can now have the molecular formula. Now let's look at the question. The question is, a compound contains 40% carbon, 6.75% hydrogen, and 53.3% oxygen. If the relative molecular mass of the compound is 180, what is the molecular formula of the compound? What is the molecular formula of the compound? Of course, it's molecular formula, not molecular mass as it is here. It's just a simple typographical error. So it's molecular formula of the compound. Now we have been given the atomic masses of the individual elements as carbon 12, hydrogen 1, oxygen 16. So we can simply calculate the molecular formula. Now, looking at the question, it is derived from the JAMB UTME 2012 question number 44. It's a question that is obtained from. So if we can solve this in class, I strongly believe that if you have this kind of question in your exam, or you come across something like this, it will be very easy for you to solve. So let's look at the solution to the question. Remember, we are not asked to calculate empirical formula, but before you can get the molecular formula, the first thing you must do is to obtain the empirical formula. You can't get molecular formula without first calculating the empirical formula. So the first thing we do is to calculate the empirical formula. So let's look at the solution. So we have component elements. We have component elements as we have carbon, we have hydrogen and oxygen. Okay, the next we do is the percentage composition. Percentage composition by mass. Percentage composition by mass. Of course, carbon has 40%, while we have hydrogen as 6.7%, while our oxygen is 53.3%. Okay, now the next thing we do is to divide the percentages, the individual percentages, by their atomic masses. So we say divided by the atomic mass. Divided by the atomic mass. So with this, we can have 40.0 divided by the atomic mass of carbon, which is 12. Here we have 6.7 divided by 1 and 53.3 divided by 16. Okay, so 40.0 divided by 12 will give us 3.3, and here will give us 6.7, while this will give us 3.3. Now, taking a look at the numbers we have here, the smallest number here is 3.3. So the next step is to divide by the smallest. Divide by the smallest number. Okay, so we have to divide these numbers by the smallest number, which is 3.3. So we can now have 3.3 divided by 3.3. Here we have 6.7 divided by 3.3. Right here is 3.3 divided by 3.3. Suppose here will give us 1, here will give us 2, and here will give us 1. So these are the mole ratios of the individual atoms present in the compound. So our empirical formula can be written as this. Our empirical formula can be written as this. So you have empirical formula. Empirical formula is equal to C1H2O1, and this will give us CH2O, ignoring the one that is there. Okay, so it has indicated the types of atoms that are present in the compound, but it doesn't go in details to show us the actual number of atoms in the compound. So here, the next thing is to look for the molecular formula of the compound given the molecular mass. Now we are given that the molecular mass, is, so molecular mass of the compound is equal to 180. So given the molecular mass, we can simply obtain the molecular formula. So we can say molecular formula is, we have bracket CH2O and is equal to 180. Okay, so by doing this, we have our carbon is 12 plus 2 multiplied by hydrogen, which is 1, plus 16 bracket n will give us 180. 180. So by doing this, we have, you sum this together, will give us 30 n equal to 180. So therefore, Rn is equal to 180 divided by 30. And this will give us what? 6. This will give us 6. So our molecular formula now, our molecular formula is molecular formula is equal to bracket C H2O bracket 6, and this will give us C6H12O6. So this is our molecular formula. So you can see how it goes in details to indicate the actual number of atoms present in the compound, which is far different from the empirical formula, which only indicates the types of atoms and the mole ratios that are present in the compound. So with that, we've come to the end of this class on empirical formula. Join us in our next class, where we're going to be looking at other examples on how to calculate empirical formula and molecular formula of a compound. So hope to see you in our next class. Bye for now.